day 5 of the observation week, and today we're going to be talking about severe weather, downdrafts, microbursts, hail, lightning, supercells, tornadoes, and tropical cyclones. So, just starting with a quick little basis on the weather right now in Houston. Tonight, patchy fog, probably because it's going to get close enough to the dew point. Yeah, I think the dew point's about 62 tonight. It's going to get down to 64, so extremely close. You're going to see that fog pop up, probably because there's a lot of moisture in the atmosphere. Tomorrow, we're going to see some pop up thunderstorms. It's going to be warm, near 80 tomorrow, and so that will increase the chance for some afternoon showers and thunderstorms, with isolated thunderstorm possible in the afternoon. Moving on to the prog charts, um, we see that dry line we've been watching, and this dry line is not a big factor, but this cold front is, and this cold front will definitely increase rain chances. And we see that cold front get down here by Thursday into Friday, and so that will definitely cool down things on Friday, with also rain chances on Friday due to a stalled out front. Um, and it's still a little bit far out, so I don't think they're very sure about how powerful or how much rain this front will create, but it should be quite a bit. And so that basically covers it for the Houston forecast. Just warmer this week, getting up to 88 on I think, let's go confirm this. Getting up to 88 on Wednesday, so pretty warm, almost 90. Getting back into the swing of things in the summer here. Anyway, we know that severe weather. Many of the severe weather events we see, especially in Texas, are mainly hail, lightning, microbursts, tornadoes, and tropical cyclones. Um, Now, the most common form of severe weather is lightning. Lightning doesn't seem like a severe weather because it's common in thunderstorms, but lightning is a killer. Lightning kills a lot of people. I don't know the exact numbers, but lightning kills a lot of Americans every year. And so lightning is definitely something to be wary of. Lightning is also very interesting because it is not a form of matter you would see on Earth. Usually, in elementary school and in middle school, we learn of three states of matter. We learn of solids, liquids, and gases. But lightning doesn't really fit any of those because it's plasma. And plasma is actually mostly the state of matter of our sun. It's gas and plasma, but mostly plasma. So yes, lightning is plasma. And so that's kind of a cool little tidbit. Lightning, however, is very dangerous, especially cloud to ground lightning. And so got to be very wary of it. That is the first type. Now, the thing I have playing right here is called a downburst. And what this is a column of cold, dry air getting pushed to the ground. And this is indicative of supercell development. And usually these microbursts only happen in supercells. And supercells are the beginning of usually a tornadic thunderstorm. And so when you see microbursts like this, that means you have a very strong downdraft, and you must have a very powerful updraft to get that effect. And so these are very high winds getting pushed out of the cloud, and it is not good news. The next thing that I had to just look up because I don't really have a hook echo like on the radar, but this is basically what a hook echo looks like. This right here is a tornadic thunderstorm, most definitely. That is a classic hook echo. And so you know that this storm is tornadic. There's a tornado in this area right here. We have a tornado. And so that tornado is probably moving due east like that. And so supercell thunderstorm with a hook echo, very dangerous. This right here is what I was talking about last time. This is called a bow echo, where you have this straight line winds, and then this thing kind of like peeled back like a bow. That's what a bow echo is. And that is also tornadic. You do not want anything to do with these. And this is also another good photo that kind of, it's not very good, but you can definitely spot some of the bow echoes. That one's pretty clear. At least it's the clearest one. You can see that little hook coming out of it. And so those are tornadic storms. So yeah, tornadoes, and this really happens in a supercell thunderstorm, where you have this updraft of warm, moist air, and this downdraft of cool, dry air, and you have a mesocyclone in the center of the storm. And the mesocyclone basically means that the thunderstorm is tilted and it's spinning, and that spinning will help spin up a tornado. And if you have a strong enough updraft, you're going to get a tornado. And so that's basically, you need a supercell thunderstorm, you need a strong updraft, and a lot of moist air to work with. And so you need that Gulf moisture, that Pacific moisture. And really, the last thing is what we talked about last time, kind of the life cycle of a hurricane. Now, this is the North Atlantic hurricane, where these hurricanes, they'll start off as a wave, and they'll turn off and go out. A lot of hurricanes do this because it just gets pulled up by low pressures, and there's sometimes subtropical highs and ridges of high pressures down here that will block the storm. But sometimes during the hurricane season, you'll get a ridge of high pressure out here in the North Atlantic, and so that ridge of high pressure will block any storm from turning to the north, and that's what forces these storms down in the Caribbean. It forces them into the Bahamas. It forces them into the east coast of the United States when that ridge of high pressure is placed here. And one time we had a storm that just went this storm became very powerful. I think it was last hurricane season, where it came off the coast of Africa and it turned and it started headed toward Europe. That is very uncommon, but it became very powerful, which was surprising because when you get up here, these waters are not very warm at all. And really just tells you, it becomes an extra tropical cyclone. And usually it transitions into a low pressure system with a warm front pushing north and a cold front pushing east. And when you have, hurricanes that get into this area, a lot of the times they'll either head up here into the east coast or into Florida, or they'll get into the Gulf of Mexico. And usually they take three paths. They either go into Florida like this, they can go into Louisiana, and sometimes they'll go into Texas or Mexico. Those are the common tracks of these storms. Doesn't mean it's always going to happen. Those are just common tracks. And really, the thing about these storms is these storms are not like dry air. These storms are heat machines, so they need warm, moist air from the ocean. So that's what they're picking up. They're picking up that warm ocean water with a lot of moisture, and that's how they power themselves. When they get on land, that moist air is mainly gone. They can't stay together, and that dry air prevails, and it breaks them apart. So that's why these hurricanes can't stay together on dry land. Sometimes you'll get storms that get on land, and they're able to maintain wind speed. There's a name for these storms. I've forgotten it, but you can look it up. And sometimes these happen where these hurricanes will come onto land, and it'll take a couple days until they really start to weaken. And Harvey weakened immensely once it made landfall, but it got into the Gulf again, and it just kind of sit there, stationary. There was no driving influence. And so Harvey was a very stationary storm for a while, and that's what kept it from getting out of here. And that's why that flooding happened, is because Harvey kind of just sat there and kept pulling in moisture from the Gulf of Mexico, and that made Harvey a very big rain threat. But anyway, that is about it. Those are kind of the severe weather. Mesocyclones, supercell thunderstorms, lightning, hail, tornadoes, and hurricanes, at least what we see in the United States. So that'll do it for the entire week. This is day 5, and that'll be the end of it. Thank you for watching.